Just an example for a question like this. So if you want to find the angle, and you have the ratio, you can think about like where is negative 5/9? Nine is the radius. It has to be positive. But if sine is based on y, if you even if you called y the negative 5/9, this tells you that the y value actually has to be negative. Um, and so there's two places that can happen. We can draw 5/9 in two quadrants, um, where we have the terminal arm, and theta is the beta is the small one that's connected. It's related to it's the acute angle, and it's always with the x-axis. Um, if you do the unit circle, you actually see that it's like the ones that are close, that are related by the x-axis, the distance from the x-axis. Those are the similar angles. Um, Theta is the bigger angle, all the way from 0 the um, to the terminal arm. And then we make our right triangle. And so there's a couple ways you can do the right triangle. You can have a hypotenuse of 1 and a y value of negative 5/9. So you imagine that this is just like negative 5/9 over 1. Or you can make a hypotenuse of 9 and a y value of negative 5. And then that would still satisfy SOHCAHTOA, sine theta is opposite over hypotenuse. So there's where the angle would be. So now all we have to do is really find beta. We just do the sine inverse of 5/9, again dropping the negative so that we are sure to get an acute angle. And then if that's 33.75, then the entire thing would be 180 plus 33.75. So that's the one place where y could be negative. The other place where y could be negative is in the bottom right. So similar triangle, you get negative 5 and 9. Beta is the inside. It's kind of a funny line there. But beta is the inside, and then theta is the outside around. And so similar, you beta would still be 33.75, but then you just ask yourself, okay, what's the rest of it? If it has to add up to 360, we can subtract 33.75 from 360. Okay. And just to verify, you can check what sine of 326.25 is and what sine of 213.75 is, and you'll get negative 0.555 repeated. With your calculator in degree mode, you can, this is another thing that will help understand if you didn't get a chance to do the unit circle. If you just do sine of every angle from 0 to 360, it's every 30 degrees, you start to see what patterns emerge. If you do it every 15, you can even see better. You can do it for cos, you can do it for tan, you can start to see these patterns. And you notice that like the angles like 30 and 150 kind of go together. They get you the same ratio, sine, cos, and tan. Um, and you start to see this repeating idea. So and then you see how it's positive in the first two quadrants for sine, and then negative after a bit after 180. So it really helps to go through this and even just write these down, sine, cos, and tan. So some patterns, sine's positive between 0 and 180, negative between 180 and 360, cosines between 0 and 90, and 270 and 360. And this is all based on the fact that sine is y and cosine's x. Tan's positive between 0 and 90, between 180 and 270. That's where sine and cosine are both positive, or the x's and y's are both positive, or they're both negative. And the values really repeat themselves. So sine of 30, sine of 150, sine of 210, sine of 330. You see that they repeat themselves as the distance from 180 and 360. So 30 is 30 away from 180, or sorry, 150 is 30 away from 180, 210 is 30 away from 180, and 330 is 30 away from 360. If your angle's in quadrant 2, your related acute angle is in quadrant 2, your theta would be found from subtracting from 180. If your related acute angle is in quadrant 3, your theta would be found from adding to 180. And if your related acute angle is in quadrant 4, your theta would be found from subtracting from 360. Couple angles. So going with those patterns, sine 30, sine 30 would really go with those 150, 210, 330. Those are the related angles. Those will have the same y values. Um, if you looked around the circle. Um, but the two that are both positive, so sine 30 is actually when y is positive. 150 works where y is positive. So 210 actually give you negative numbers. Similar for 45. 45 is kind of like 135, 225, 315. But cosine's positive where x is positive. So 315 is going to be the other one where x is positive. Tan 60, 60 goes with 120, 240, and 300. But 60 is where tan's positive, where x and y are both positive, because it's based on opposite and adjacent. Where they're both negative is in the bottom left quadrant. The third quadrant, it's at 240 degrees. 150 goes with 30, 210, and 330. Those guys are related to 150. Cosine is cosine at 150 degrees. Cosine is negative because the x values are negative. It's also negative for 210 degrees. Okay. These angles are actually all referred to as the special angles. Those are the ones we found from the special triangles. So we can actually, if we wanted to get these ratios, we can get actually exact values for these. And because they're all related on 30, 45, and 60. That's just a note for these ones. Finding all the angles from 0 to 360. So sine theta is 0.891. So we can find the first one because the sine is positive. So we know that it's in the top right quadrant, the first quadrant. So the first beta is actually 63 degrees. So to find beta, we just do the sine inverse of 0.891. So we get 63 degrees. And so since we want to find out where 63 degrees is positive, it's positive where y is positive. And so so theta actually equals 63 degrees. That's the first answer. The second answer is in quadrant 2, where we can even draw it out, 63 degrees from 180. And so 180 minus 63 is 117. And you can evaluate this and say sine of 63, sine of 117, and double check. For a question like this one, it's secant. So to deal with secant, you actually just take the reciprocal. So if we could call this like over 1, we can change this to cosine theta of 1 over. Now, if you do the cos inverse of 1 over this, you actually get an error to find the beta. And the reason why is, and you can think about it, but remember that cosine is based on adjacent over hypotenuse. And then tan theta, we want to find out the angle that gives you 1. And so we know the related angle is going to give you 1. So if we do the tan inverse of positive 1, we actually get 45 degrees. Now we don't want 45 degrees in the first quadrant because tan isn't positive in the first quadrant. Tan is positive in the first quadrant. Tan is negative where either x is negative and y is positive, or y is negative and x is positive. So in the top left quadrant, x is negative, y is positive. So we do 180 minus 45 for the first one, 135. And then in the bottom right quadrant, x is positive and y is negative. So 360 minus 45 will get you the other answer. The only other one you would try is 225. But 225, x and y are both negative. So that would give you a negative or a positive one. Drawing these are the special triangles as well. We can graph sine 135. We can actually draw the special triangle at 135 degrees. 135 makes a related acute angle of 45. Now we know the 45 degree triangle is 1 root 2, but the x is negative 1. So sine of 135 is opposite over hypotenuse, 1 over root 2. Cosine would be negative 1 over root 2. Similarly, drawing 240, um, sorry, it also asks you want to find another one that has the same ratio, 135. Y is also positive, or since this answer is positive, we'd also get the same thing as if we did the sine of 45, where y is positive in the first quadrant. Drawing 240 degrees is higher than 180, less than 270, so that's 240 degrees. That creates a beta of 60, so you can actually draw the special triangle, and it's the 2, 2, 2 triangle cut in half. So the hypotenuse is 2, the adjacent side is -1, and the opposite side is -√3. Notice that these are both negative because the coordinate that we make is in the bottom left quadrant, where x and y are both negative. So cosine of 240 is adjacent over hypotenuse, -1/2. Cosine is also negative in the top left quadrant, and so we could also do, so the other angle we could use is 180 minus 60. 120 would also give us -1/2. The other one that would go with it is 300, but that would give you +1/2, because the triangle would be down here where x is +1.